first part is given to us already.
You have to show that f of x equals, well, the limit of f of x equals g of x, the limit of g of x.
Very good. When x approaches 4, 4x minus 9, and the limit as x approaches 4 from x squared minus 4x plus 7. Before you calculate, what happens if these two are not equal? Let's say this one is 10 and this one is 12. What do you conclude? Can you conclude anything?
You can't conclude the limit.
The squeeze theorem is not applicable. Awesome. Excellent. Good. So what is the first limit, please?
7.
Excellent. What is the second limit, please?
7.
7. What do we conclude from 1 and 2 by the squeeze theorem? What do we conclude?
The limit as x approaches 4 of f of x equals 7.
That's it. Awesome. Great job. Good. I don't have anything else to say. I mean, we can continue practicing later on, unless from this section, sorry, except these. They are absolute value functions, and they're extremely important, and we have to choose from here. And the rest is really, we can look at a piecewise defined function, which we already did 3 or 4 times already. That's why I did it from the very beginning, so there is no discussion and, you know, everything goes smoothly. So I think we're okay with that, but I think we have to go back and address the absolute value. And that will be it, and we can move on to 2.4. When I say that, I always include assuming you have no questions. If you have questions, I'll stop at any point in time. Okay, so anyone would like to choose any of these absolute value?
45?
45. Let's start with 45. Which one was the other one?
Oh.
Which one was the other one that you wanted to pick? Or was it the same? Okay. Good. So, oh, of course I switched, but I didn't copy it. Wonderful. So limit as x approaches 1/2 from the left, from 2x minus 1 over 2x cubed minus x squared. Perfect. Okay. Yes, I have to review with you the absolute value, so there is a little bit of a story before we even move on to that. So does anyone remember the formal definition of the absolute value? Anyone?
What does it do with the distance from 0?
Correct. But that's so indeed the absolute value of 2 is 2 because it's 2 units from 0. The absolute value of -3 is 3 because -3 is 3 units from 0, away from 0. I completely agree. But the formal definition when we do not have x. Anyone remembers this? So from now on, please remember it so we don't have to go back to it. So it's the absolute value of x can be replaced by x if x is a positive number or 0, or it will be replaced by negative x if x is negative. But this is for x. In general, any expression in absolute value, because I don't have x, I can have anything. Any expression in x or variable is the expression itself if the expression is greater than or equal to 0, or negative the expression, the opposite of the expression, if the expression is negative. So what I'm asking you to remember here is something very simple. This, and this are all the same for any expression you are facing. So I'm going to start with a simple one before we look at that one. So can anyone give us the absolute value, let's say, of -1? How will I have to write this? Can anyone just mimic all these?
So for x minus 1,
Excellent.
x greater than or equal to 0.
Right. No.
It can't
Is
even.
it x greater than or equal to 1?
Yes. But I want everyone to see this first before x greater or equal to 1. I completely agree with this, but I want everyone to see that I'm simply mimicking x and putting here x minus 1. That's all I need for now. But yes, I completely agree with that. Next one.
And then negative x.
Careful, you have to say something else. Negative what?
Negative x plus 1.
Correct. Or you say parentheses for everyone to see that I'm mimicking exactly what I said. 1, 2, 3, 4, 5 are identical. 1, 2, 3, 4, comma, 5 less than 0. Then, yes, I will clean it up. I will distribute -1 here. I will say if this is greater than 1, I will never solve this one. I don't care. If this one is greater than or equal to 1, this must be less than 1. Don't even look and waste your time on that. If this gives less than or equal to 1, then this must be greater than 1. Good, so this is an example. Now let's go back to our function. At this point, I cannot even plug it in before I simplify this. So the problem will ask us to simplify the absolute value, to simplify the function, and then plug in whatever. If you want to right here, we can. So let's see what the numerator, where the numerator is going and where the denominator is going. What will you say about the numerator? Where is the numerator going?
Can't you just leave it as 2x minus 1?
Where is it going?
Oh.
Yes, it is 2x minus 1, but I'm talking about the limit.
0.
Yes, I agree. Where does the denominator go? So you can plug it in. It's 2 over 1 over 8. So this is 1 over 4 minus 1 over 4. Just plug it in the calculator if that's what you want to do. So this is 1 over 8 with 2 in front, which becomes 1 over 4, and this is 1 over 4. 1 over 4 minus 1 over 4 is?
0.
Good. So there is hope. No guarantee, but hope. Good. So now I'll take the function aside. So one more time, this is our function. 2x minus 1 over the absolute value of 2x cubed minus x squared. And this is my page 5. Okay. So first we want to simplify this function without the absolute value. So we'll start with 2x cubed minus x squared. And what are the options?
Pull x squared out to make it x squared times 2x minus 1.
It's a good suggestion. I agree with that, but now I have to talk about something else. A times b in absolute value has to be written as the absolute value of a multiplied by the absolute value of b. So perfect suggestion, I completely agree with 2x cubed minus x squared equals, pull inside x squared and then 2x minus 1. But then I have to show this property. This is the property of absolute value. I have to show it step by step. So I will write the absolute value of x squared multiplied by the absolute value of 2x minus 1. And yes, now I can omit the absolute value on x squared. How come and why?
It doesn't matter.
Because it's always positive. That's why it does not matter. So I agree with that. So there is also a second property of the absolute value, which is this. We're going to use it in the next section, so I need both. So thank you for saying that. So the absolute value of A over the absolute value of B. So these are properties of the absolute value, and they have to be emphasized whenever we apply them. Good. So then I don't really need this, because now the function equals 2x minus 1 over x squared, the absolute value of 2x minus 1. Awesome. Thank you for the suggestion. Who was that? Was it Brian?
Yes.
Excellent. Perfect suggestion. You saved me from doing it a longer way. Excellent. Good suggestion. Good. So then our function now becomes, now I only have to show the absolute value of 2x minus 1. And then we'll simplify the function. Great job. Good. Can anyone tell us what to write? We just did the same thing a minute ago for x minus 1. Can anyone dictate?
2x minus 1 is greater than or equal to 0.
So if.
Or if.
So 2x minus 1 if 2x minus 1 is greater than or equal to 0. Don't solve anything just yet. And what is the other option?
Negative parentheses.
Excellent.
2x minus 1. If 2x minus 1 is less than 0.
Awesome. Great job. Who was that? Caitlin, thank you. Okay. So now our next step is to simplify here to solve this, right? So I have the absolute value of 2x minus 1 is 2x minus 1. You can leave this alone. And you can say, why? You just told us to distribute here. Only because the numerator is 2x minus 1. I'm looking ahead a little bit. That's why I will not distribute. Is it wrong if you distribute? No. But then you will have to factor out to simplify. So that's why let's leave it alone. So how much is here? X what? Can anyone solve this inequality for us? And tell us what happens to x?
This equals 1/2.
But this is not the equal symbol, right? You are on the right track, but this is not the equal symbol. I cannot change it into the equal symbol.
Like X.
So greater than or equal to 1/2. So I don't even have to look at this. What do I have to write here?
Less than.
Less than 1/2. And I will keep it as is. Okay, finally, after all this explanation and detailed step-by-step work, now I can write that 2x minus 1 over x squared. Ah, I didn't mean that. 2x minus 1 equals. So if the denominator has two options, the function will have two options. Can anyone tell us what are the options for this function? I'm ready. What would be the first option? When x, unfortunately, I cannot put the equal symbol here. Why? Can anyone explain, first of all, why I cannot put the equal symbol? I had the equal symbol here, but I cannot put it here.
Because you can't divide by 0.
Exactly. Thank you. Great job. That piece is in the denominator. I cannot have equal to 1/2. Awesome. Good. Then, and I'll copy the second one. No problem there. But can anyone tell us what to write here and here?
Because don't we have to write the whole function there? Because you said earlier we had to mimic it.
Not anymore. I'm not anymore. I mimic only the absolute value. I don't mimic anything else. This is a combination. I mimic only the absolute value. This is only for the absolute value and nothing else.
Okay, thank you.
Thank you. So can anyone simplify this function and tell us what to write here when the absolute value of 2x minus 1 can be replaced by 2x minus 1?
Is it 1 over x squared?
Brilliant. Can anyone simplify when the bottom now is negative 2x minus 1 and tell us what to write?
Negative 1 over x squared.
Brilliant. Now I'm in business. My limit is asking me to find the limit as x approaches 1/2 from the left from this function. I'm not going to even copy it. I don't care. It's that function. Okay. But now the question is, which branch am I looking at? It can be both. Because this clearly states as x approaches 1/2 from the left. Which of these two will I copy in here?
It would be the negative 1 over x.
Awesome! Exactly. That's the one I copy because x is less than 1/2. If I had plus, I would have copied the top. Awesome! What is the answer now after all this work? Negative 1 over 2 squared. And the answer is?
Negative 4.
Negative 4. Great job.